Hi everyone, I am Dr. Surjit Singh. In this video on Python via examples, we shall talk about a numerical problem. Let us begin. In this session, we will formulate a number problem. Find the smallest number of which when digit at unit place is shifted to its beginning, that is extreme left, the new number is 1¼ times the original number. Note that the number of digits are equal in both the original and the new numbers, and the digit transferred is not 0. This is an interesting problem in the number theory. We will now formulate the problem. We are to find a number that has n digits. Let these digits be a1 to an. We rename the last digit as d, that is the digit at the units place. We now move the digit d to extreme left of the number to get a new number. Total number of digits of the new number remains the same as that of the old number, but the place value of d increases while those of the remaining n-1 digits decrease. According to the problem definition, we are to find the smallest such number for which the new number is 1¼ times the old number. This means that the number of digits is not known. However, it is given that both a1 and d are non-zero digits, so the required number has at least 2 digits. You can take a pause here and try to solve this problem using paper and pen. This is not a simple problem and may take you a while. After this, you can proceed to follow my solution to the problem and compare it with yours. I will now start with my solution. We express the old number as AD. A consists of the first n-1 digits of the number excluding the last digit that we have named as D. Therefore, the number is 10a plus d. The new number is 10 to power n-1 times d plus a. According to the given condition of the problem, 5 times the old number equal to the 4 times the new number, which means that 50a plus 5d equal to 4 into 10 to power n-1 times d plus 4 times a. The hitch is that we do not know the number of digits n present in the old number. Let us now separate the terms of a and d. That gives 46 times a is 39995 times d, from which we get a by d. From this single equation, we have to find the values of two unknowns a and d. The additional fact that we will use is that both a and d are whole numbers and not fractions. Moreover, d is a single digit. Now, we notice that the denominator of the ratio is 46. We factorize it and retain only the single digit number in the denominator. It is clear that only value of d is 2 and a is the ratio as shown here. This is where we use our logic. According to the definition of the problem, a cannot be a fraction. So, number of 9s between 3 and 5 should be such that the numerator should be completely divisible by 23. Further, the problem requires that a should be a minimum, which means that we use minimum number of 9s between 3 and 5 for which it is divisible by 23. After the derivation of the relations, we proceed with the numerical calculations. In order to find a, let us start dividing the numerator by 23. We start with the dividend without any 9 and try to divide 35 by 23. We notice that 35 is not divisible by 23 and the remainder there is 12. So we insert a 9 between 3 and 5 and the remainder changes to 16. We may try bringing down 5 and continue with the division only to find that even 395 is not divisible by 23 as the remainder there is 4. So we add another 9 and the remainder changes to 8. We now bring down 5 to find that for 3995 also division by 23 gives the remainder as 16. So we insert another 9. If we bring down 5, the current term will be 205, which will also not be divisible by 23, and we have to add another 9. Even now also we cannot bring down 5 because even 25 is not divisible by 23, so we must add another 9. Remainder at this stage is 6. This will give the current term to be 65. Even 65 is not divisible by 23. We keep on adding 9s and continue with the same division till the remainder is 11. This is the remainder when we can bring down 5 because the number 115 is divisible by 23. Ultimately, our effort is rewarded and the division process is over. Notice that division by 23 can give 23 different remainders ranging from 0 to 22, out of which only 11 is good for our job. If the remainders start repeating themselves without the required value, it will mean that the problem does not have any solution. After the division process is successful, the quotient becomes the value of A. We now know both A and D, and AD is the required number, so we append D at the end of A to get the desired answer to the problem. We can verify that if we multiply it by 5 by 4, we get the number in which 2 shifts to the extreme left. Obviously, it is the smallest such number. As an exercise, we consider a variation of the same problem. Instead of 5 by 4, we revise the ratio to be 3 by 2. You should follow the same procedure to find the number that is 1.5 times the original number. You may take another pause to solve it. In this case, the relations change as shown. Let us again separate the terms of A and D. That gives 28 times A is 1999997 times D. From this, we find the ratio A by D. Denominator of the ratio this time is 28. We factorize it. Numerator cannot be divided by 2 or 4, so we can only try 7 as its possible divisor. So only possible value of D is 4 and A is the ratio shown here. To have minimum value of A, we use minimum number of 9s. Let us now evaluate A. Now 17 is not divisible by 7 and the remainder there is 3. So we insert a 9 between 1 and 7 and the first remainder becomes 5. Even 57 is not divisible by 7 and the remainder is 1. So we insert another 9 in between 1 and 7. The same remainder changes to 3. Bringing 7 down shows that for 1997 also division by 7 gives 2 as the remainder. So we insert another 9. If we now bring 7 down, the current term will be 47, which is also not divisible by 7. So we have to add another 9 and the current term becomes 49. That is divisible by 7. Even after we bring down 7, the number is divisible by 7. So we now bring 7 down and the division process is over. The quotient now becomes the value of A. We know that AD is the required number, so we append D at the end of A to get the desired answer to the problem. We can verify that if we multiply this number by 3 by 2, we get the new number in which 4 shifts to the extreme left. You can try similar problems for different ratios and analyze the results. In the next part of this video, we shall write the Python program for this problem. In this session, we formulated a problem in which the new number is 1¼ times the old number. The solution reduces to d is equal to 2 and a equal to the integer value of the division using minimum number of 9s. A is an integer if we use a minimum of 20 9s between 3 and 5. The method was generalized for other ratios between new and old numbers. Hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more such videos.